This is section 10.6, 10.7 on proofs of some of the theorems involving segments and circles. So our first one here says, find the measurement of angle 1 in terms of x and y. So x and y are the arc angles. If this angle 1 was a central angle, then it would be equal to angle x on the left, the same thing as angle y on the right. Unfortunately, it's not, so it's not so clear-cut. So make a hypothesis. How do you think measure of angle 1 is related to both x and y? When you're ready, you can unpause the video. So what we're going to do is draw in this auxiliary segment that creates angles 2 and 3. And angle 2 is an inscribed angle. Angle 2 is 1/2 the measurement of y. Angle 3 is an inscribed angle. Angle 3 is 1/2 of x. And then using the exterior angle theorem, which says that this exterior angle 1 is equal to the sum of those two remote interior angles, measure of angle 1 is equal to measure of angle 2 plus the measure of angle 3. Now making a substitution, angle 2 is 1/2 y. Angle 3 is 1/2 x. If we factor the 1/2 out of both of those, we have 1/2 of y plus x. In other words, this angle 1 is x plus y divided by 2. Angle 1 is the average of x and y. Second situation, we have those same two segments intersecting, those two chords are intersecting. The goal here is not to find an angle measurement relationship, but find a relationship that measures the lengths of these segments. So there's a total of 6 segments, DH, HE, and DE, GH, HF, and GF. What's the equation that relates all of those with each other? Let's see. So if you draw in some more auxiliary segments, draw in DF and GE, we can start to get an idea of what this relationship is going to be. Measure of angle 1, this inscribed angle, is 1/2 of measure of arc FE. Angle 2 is also 1/2 the measurement of arc angle FE. And if you recall, if two angles are both inscribed inside of the same arc angle, then those two angles, in this case 1 and 2, must be equal to each other. So measure of angle 1 is equal to measure of angle 2. Likewise, angle 4, angle 3 are both going to be 1/2 of DG. So measure of angle 3 and measure of angle 4 must be equal to each other as well. So here's angle 3, there's angle 4, those are equal. If I want to go one step further, look at this, these vertical angles are equal. Plenty of information by angle to get those triangles similar to each other. Triangle DHF is similar to triangle GHE because of angle similarity. And since corresponding sides of similar triangles are proportional, DH from this triangle on the left is corresponding to GH on the right. FH from this triangle on the left is corresponding to EH. So those corresponding sides are proportional to each other. If you cross multiply, DH times EH is equal to GH times FH. Look back at your drawing. DH times EH, so the two segments that make up this chord multiplied by each other, is equal to GH times FH, the product of those two chords. Next, instead of having two segments that intersect inside of the circle, now we have these two secants. Secants are segments that extend beyond the circle. So these two secants intersect at angle 4. What's the relationship of measure of angle 4 relative to this arc angle that's inside of it and this arc angle that's inside of it? And I can tell that this green arc angle on the right, which is the same as this central angle, is definitely going to be less than this arc angle on the left, which is that bigger central angle. So they're not the same size as each other, but how can we figure out the measure of angle 4 using those two angles? So for this one, maybe you want to pause and see if you can work forward on this one on your own. Here are the auxiliary segments that you're going to need to draw in there. And I put some labels in there because of all the isosceles triangles, X and X, WW, VV, YY. All those isosceles triangles have the isosceles triangle theorem, which tells us that those two angles are going to be equal. Because KMNL is an inscribed quadrilateral, that means that opposite angles are equal to each other. So I can say that this angle and this angle add up to 180. X plus W plus Y plus V. Next step. Since we have triangle KLJ, that those angles add up to 180 degrees. So X plus W plus J plus Y plus X equals 180. So X plus W plus X plus Y plus J equals 180. So then, using a transitive property, since this equals 180, and since this equals 180, we can set those equal to each other. And I'll go ahead and put that up here. On the left, I'll take X plus W plus Y plus V. On the right, X plus W plus X plus Y plus the measure of angle J. So again, transitive, these are equal to each other. Let's subtract an X and a W from both sides. We can subtract a Y from both sides. So now V is equal to X plus the measure of angle J. Measure of angle J, if I subtract X from both sides, measure of angle J is equal to V minus X, which is simplifying down quite a bit. The goal was to figure out the measure of angle J in terms of these arc angles on the inside. And I've almost got it. So this angle J is equal to V minus X. How can we go further with this one? Let's see. If I look inside of this triangle, measure of 2 plus V equals 180. Let's put this up here. Measure of angle 2 plus V equals 180. So if I subtract angle 2 and divide by 2, then V is equal to 90 minus 1/2 the measurement of angle 2. And because of this gray triangle over here, X plus 3 equals 180. So 2X plus measurement of angle 3 is equal to 180. I want to make a substitution down here, so I'm going to solve this equation for X. Subtract 3, divide by 2, and X is equal to 90 minus 1/2 the measurement of angle 3. Now let's take what V and X are equal to, substitute them back in down here. V is equal to 90 minus 1/2 the measurement of angle 2 minus X. X is equal to 90 minus 1/2 the measurement of angle 3. Again, I took these two yellow equations and substituted them into this. Now, if we simplify, 90 minus 90, gone. Negative 1/2 measure of angle 2 minus the negative, which means that this back part is a positive. So the measurement of angle J is 1/2 measurement of angle 3 minus 1/2 the measurement of angle 2. We can factor 1/2 out of both of those. Measurement of J is 1/2 the quantity of measure of angle 3 minus the measurement of angle 2. And let's go back to this original drawing. By definition, this central angle is equal to that arc angle. This central angle is equal to that angle. So when it says angle 3, we can call that the measure of KL. When our equation says measure of angle 2, we could call that MN. So final here, measure of angle J is equal to 1/2 of measure of KL minus the measure of angle 2, which is arc angle MN. Oof, that's a doozy. In other words, up here, this angle 4, angle J, is equal to 1/2 of big green arc angle minus small green arc angle. measurement of arc angle KL minus the measurement of arc angle MN divided by 2 is equal to angle 4. Let's look at another one. Once again, we have two secants. The secants are intersecting outside of the circle. And instead of trying to find the measurement of angle J, the intersection of those two segments, let's find an equation that relates the segment lengths with each other. So 6 segments, JN, JL, NL, JM, JK, and MK. Of those 6 segments, there are 4 which will be used in the equation that we're looking for. First off, draw in KL and MN, two auxiliary segments. And what I know is that because this is an inscribed quadrilateral, the opposite angles are supplementary. So 1 and 2 are supplements. 3 and 2 form a linear pair, so 3 and 2 are supplements. That means 1 plus 2 equals 180, 3 plus 2 equals 180. Transitive, you can set them equal to each other. 1 plus 2 equals 3 plus 2. 2 equals 2 reflexive, subtract it, and you're left with measure of angle 1 is equal to the measure of angle 3. This angle has got to be equal to that angle. Get rid of this color now. Measure of angle J is equal to itself, which, okay, great news. But what that does for us is it gives us this small yellow triangle, angle, angle. This bigger orange triangle has the same angle, angle. So now we know that yellow and orange must be similar to each other because of angle, angle similarity. Triangle KLJ in the big orange, single marked, no marked, double mark, is similar to single N, no mark, M, double mark J. Those triangles are similar to each other. Since the corresponding sides of similar triangles are proportional, JM from this triangle is corresponding to JL from the other triangle. JN from this triangle, JN corresponds to JK in the other triangle. Cross multiply. JM times JK is equal to JL times JN. If I go back up here to my drawing, JM times JK is equal to JN times JL. Nice equation to have. And these are quite a few equations. So here is all of the formulas we've looked at so far. When two segments intersect inside of a circle like the chords, we have an equation representing the segment lengths, and we have an equation representing the angle measurements. Notice that in the segments, point K is the most important one because it's in all of those segment names. KP times KJ equals KH times KL. Angle 1 is inside the triangle, so you add together and divide by 2. Inside, we're adding and dividing by 2 for those angle measurements. Ooh, boy, look at all these. When two segments intersect outside of a circle, so we just had two segments intersecting inside of a circle, two segments intersecting outside of a circle, like J, J, and J. For the segment formula, notice all of these have the letter J in them. From JM times JK equals JN times JL. And this time angle J is outside. If it's outside, we subtract big arc angle minus small arc angle divided by 2. And it's the same concept for these other ones. JN times JL equals JK times JK, or JK squared. Big arc angle minus small arc angle divided by 2. Outside, we subtract and divide by 2. Last one, recall that from a point outside of this, those two tangent segments must be the same. So JC equals JB. And again, big arc angle minus small arc angle divided by 2. Outside, subtract and divide by 2. Inside the circle, outside the circle, on the circle. So if two segments intersect on the circle, then this angle B is 1/2 the measurement of this arc angle. It's like an inscribed angle. And that this is the inscribed angle. Angle B is 1/2 of arc angle FE. Notice there's no segment equations relating those segment lengths. It's all about the angles for this specific one.